We are looking at post-UTME, UTME, JAMB, SSCE, GCE, IDSC, Junior, Olympiad, etc. Related preparation, competition, examination around this. We are looking at part volume 3 of it today. And in volume 3, we shall be looking at the following topics: ions, its electronic configuration, what is meant by isoelectronics, substitution, that is in mathematics, the first one is in chemistry, variation part 1, that is mathematics, isotope, isobars, isomers, we will try to differentiate them, radioactive decay, particles, nature and their properties, we'll quickly briefly look at that, then balancing radioactive equation. How is radioactive equation balanced? Alright, now we look at this. Let's start with the first one. Ions, its electronic configuration, and isoelectronics. Now, you see, elements or substance represented as X with atomic number and with atomic number and mass number is represented as this. Okay, where this is mass number, where this is atomic number. Now, when this element is excited, take note of that. When it is excited, it either loses electron or gain electron. So two things happen. It either become X plus N or it become X minus N when it is being excited. That means when you subject it to a situation where it can either gain or lose. Now, when it becomes this, then it has turned to ions. Now, this one is when it loses electron. It becomes positive. It carries a positive charge. It is negative when it gains. When it gains electron. We take a typical look. Now, generally, metallic elements loses electron to become ions, while non-metals gain. Okay, so they are also always at the receiving end. They always gain. The metal loses. Okay. Now, principally, we know that a typical example of metal could be sodium, magnesium, then aluminium. Now, this is sodium is 11, magnesium is 12, aluminium is 13. Now, if you look at this, it is the valency electron, okay, that participate in the losing or gaining process, the valency. For sodium, it is 281. Magnesium, it is 282. For aluminium, it is 283. Now let's look at some non-metal: fluorine, chlorine, and oxygen. Fluorine is 9, chlorine is 17, oxygen is 8. The electronic configuration of this is 27. Chlorine is 287 and oxygen is 26. The electronic configuration. Now, this is at their elemental state, when they are element, pure element, pure. Okay. Now, once they are excited, these ones that are metals, these are metals, these are non-metals. Okay. Now, when metals are excited, they give up their valence electron. The valence electron is the number of electrons in the outermost shell. Okay, they give it up. Now, but that means they lose. But with these ones, the non-metals, they gain electron to fill up their outermost shell. Like this one now, it needs one more electron to fill up its outermost shell. The same thing, one more electron. Okay. This one need 2 more electrons to fill it up outermost shell. Now, bonding only takes place when octet structure, or duplets. That means when the outermost shell is filled with 8 electrons or is filled with 2 electrons. Take note of that. 1 or 2 elements come together once an octet structure is being formed. Now, once this one, sodium, loses electron, it becomes sodium ion plus 1. This one loses 2 electrons, it becomes magnesium plus 2. This one, once it loses electron, it becomes aluminium. Okay, that is 3 electrons, the Al3 plus. Now, fluorine gains 1 electron to become F minus 1. Chlorine gains 1 electron to become chlorine minus 1. Oxygen gains 2 electrons to become oxygen 2 minus. Sorry, I can write this like this. Minus, okay, then 2 minus. This one means 1, okay, we don't need to, usually we don't normally indicate it. Now each of these also have their own electronic. Now, so if I gave you something like this, that an element in ionic state is this, and is having this. Okay, now initially, before this element gain this 3 electrons, this element gain 3 electrons, It means the number of electrons has increased. So total electron now will now be this 15 plus 3. Because the atomic number, take note of that, atomic number is equal to number of electrons is equal to number of protons. This atomic number, okay, is equal to number of electrons, number of protons in an atom. So when an atom becomes ionized negatively, the number of electrons increases to 18. So it means that the electronic configuration of this becomes 288. Is that clear? Then for element like aluminium, 3 plus, which is literally this, so for it to be 3 plus, it means it has lost 3 electrons. It lost 3 electrons. So it means the total electron left now is 10. It's 13 minus 3, which is 10. So if I ask you to add the electronic configuration of this, it will be 2,8. All right. So now that is that. So we have seen ions, how ions are formed. We have seen the electronic configuration of elements and ions also. Now isoelectronics. When you say isoelectronics, it means 2 elements or 2 particles or 2 ions, element and ions or whatever, having the same number of electrons. Electronic means number, iso means the same number of electrons. For example, let's look at sodium ion and neon. The atomic number for neon is 10, sodium is 11. Now, sodium ion, because it has lost 1 electron plus 1, the number of electrons that remain here is 10. Neon cannot gain or lose. They are inactive element. They do not gain electron, they do not lose electron. Neon. So it means the number of electrons remain 10. So it means that sodium ion and neon are isoelectronic because they have the same number of electrons. So I believe you have gained 1 or 2 things from my explanation. Okay, thank you. Let's go to the next topic. So the next one we have is substitution. That is in mathematics, substitution. Now let's say you are given x to be minus 1, y to be minus 2, z to be 3. And you have to evaluate this. Look at this. You have to evaluate x, y squared, okay, z minus 3, z raised to power minus 1, okay, plus s, y, z raised to power minus 1, okay, plus z cube, z plus z cube. Now let's say you are giving this to evaluate value, given the following value. Now the secret about substitution, irrespective of the way they gave you, is that when you are making that substitution, make sure you put it in bracket while you are replacing it. So f is minus 1, so you put minus 1 in bracket. Then y is minus 2, you put minus 2 in bracket squared. Z is 3, so you put 3 in bracket minus 1. Okay, plus, you put plus. Now, s, y, z, so this one you open it at 1 bracket first. X is minus 1, y is minus 2, z is 3 in bracket. Make sure you put f there raised to power minus 1, then plus z, that is 3 raised to power 3. So when you are doing substitution, the secret is that just make sure you put everything inside. Then you now begin to take it 1 by 1. This is minus 1, minus 2 squared is 4, 3 raised to power minus 1 is 1 over 3, okay, law of indices, okay, now plus minus 1, minus 2, this one in that bracket, you handle it first, minus 1 times minus 2, that is 2, 6, that will be 6 raised to the power minus 1, okay, plus 3 raised to the power 3, that's 27. This gives us minus 1 times 4 times, that's minus 4 over 3, plus 6 raised to the power minus 1 is 1 over 6, law of indices, then plus 27 over 1. Now look at it. You have to find the LCM. What is the LCM of 3, 6, and 1? The LCM is 6. 3 in 6, 2. 2 times minus 4, minus 8. 6 in 6, 1. 1 times 1, plus 1. 1 in 6, 6. 6 times 27, 27 times 6. This is 42. This is 12, that's 16. 162 plus 162. Now, minus 8 plus 1, that's minus 7 plus 162 divided by 6. Between 162 and 7, the greater is 162. So the plus is in front of 162. You put plus. Then you take away 7 from this. 7, that's 12, that's 5. That's 5, that's 1. So that is 155 over 6. So substitution normally comes in this perspective. So the secret is that when you are doing substitution, the expected is that whatever thing you are replacing, you put it in bracket. So that is all you need to know about that, and the question can come in varieties of ways. Is that clear? Then we look at variation. Now we shall be looking at part 1. Okay, that is direct variation and inverse. This is mathematics also. Now in direct variation, it means two variables are connected. Okay, either in an increasing way or reducing way. The two of them are going in the same direction. Like this one now, and it means x varies directly as y. Now, this one to be removed is not acceptable in mathematics. You have to replace it with a constant. When you change this to equals to, then you introduce a constant. Okay? Then for inverse variation, two of them, one is increasing, the other one is reducing. Or one is reducing, the other one is increasing. It means two variables, two quantities are going in the same direction. I repeat again, for direct, as x is increasing, y is increasing. Or as x is reducing, y is also reducing. But for that is direct variation. But for inverse variation, I can say x is inversely. Inversely means 1 over y. They are going in contrary direction. One is increasing, the other one is reducing. One is reducing, the other one is increasing. So that it means x varies inversely. Inversely means 1 over this. Now, this is not acceptable in mathematics. You change it to equals to. Now, because you have done that, you have to introduce a constant. Okay? Then there is the relationship. So they will give you some values that will enable you to find your k. Then they may now ask you to find either x or y, and vice versa. Take note for the use of words like square, square root, cube root. While they are discussing, I'll give you problems on variation. So problems like that, you watch out for that. If you want to understand that properly, you go to GSS 3 maths textbook. It's also in SS1 maths textbook. Then there's a revision of that in the senior secondary school 3 textbook. We are in part 4 now. Now, we want to differentiate between isotope, isobars, and isomers. Isotopes, isobars, and isomers. We quickly look at this. Now, isotopes are 2 or more elements. This one, elements having the same atomic number. 2 or more elements having the same atomic number but different mass number. Okay? Now, two elements of the same source, of the same atom, but they are having the same atomic number but different mass number. Then isobars, 2 different elements having the same mass number but different atomic number. Okay? Then isomers is a situation whereby a compound with a particular molecular formula, maybe this, or this, or this, that is alkanes, they have the same formula, they correspond to the same formula, but they have different structural formulas. Okay, they are from the same formulation, but structurally they are different, and because their structure are different, they are different compound entirely. Now, a good example for isotope, we have chlorine 17, 35, 37. We have hydrogen 1, hydrogen 2, hydrogen 3, 1. Okay, we have oxygen also, oxygen 16, oxygen, this is 8, 17, oxygen 8, 18. Okay, then we have uranium 92235, uranium 92236, uranium 92237. Then for isobars, okay, look at this. Then we have helium. Okay, no, sorry about that. Then we have isobars. Now for isobars, we have something like helium. There's helium 42. Then now, if you look at hydrogen, there's also hydrogen. I'm trying to. Okay, we have helium. Yes, under isotope, helium 42. Then we have another helium, that is helium 32. That's what I'm doing. Helium is also isotopic. Okay. Now, if you pick one, then there's another. The main helium is helium 42. Then if you look at this hydrogen, hydrogen 3, 1. Okay, it's sharing the same. It's sharing the same mass number with helium 32. This helium 32 is sharing the same mass number with it. Okay, so now if you want to get details about this, I would advise you search for my videos on isotope, isobar, isomers. I really go into detail to explain the differences. The characteristics of each one of them is discussed. What they share in common, what is their differences, what is their chemical and physical differentials were being discussed. So please search for my videos on isotope, isobar, isomer, and isoelectronics for details on that. Now, we are now in number 5, radioactive decay. Now, we have radioactive decay. Radioactive decay. Now, radioactive decay. Now, an atom is made up of nucleus and shell that carries electrons. Shell that carry electrons, right? Okay. Now, the nucleus, this is nucleus. The nucleus is made up of protons and neutrons. Now, the shell carries electrons. These are the shell. So, inside the nucleus is centrally located. Now, the difference between these two particles, electron, which is being arranged along the shell or orbit, you also call it orbit, and the protons plus neutron is this. Now, electron is the one that is responsible for chemical reaction. What we call redox reaction, reduction oxidation. An element is either gaining or losing before they can be bonded together. That a good example is our sodium chloride. Okay, sodium and chlorine. For them to have become sodium chloride, which is the common salt, then one element has gained and one element has lost. Then the protons is responsible for nuclear reaction. Watch out for differences between chemical reaction and nuclear reaction under this series of discourse, okay? Under this series of communication. But that's our bone of contention. So now, some elements are naturally stable. Some are naturally unstable. The unstable one undergo nuclear reaction. Nuclear reaction. We said they are radioactive. Okay? The stable one do not undergo natural radioactivity, even though they can undergo artificial when you disturb their nuclei, when you bombard their nuclei. But naturally, they are non-radioactive, the one that are stable. Now, a good example of elements that are stable are elements that we found as the first 20 elements. The first 20 elements are naturally stable. Okay, from hydrogen to calcium. Hydrogen to calcium are the first 20 elements. Now, but in the periodic table, elements under the lanthanines, actinides, are often associated with instability in their nuclei. Now, what then causes radioactive decay? Now, what radioactive decay is when these elements that are unstable wanted to attain stability. In the process of doing that, they produce their kind. The release of particles and mass energy is also being released. Okay? So now, naturally, what causes that? Let's look at the difference. The first element to have been observed to be radioactive is uranium. Uranium 92235, which is also, of course, it is also radioisotopic. It exists in varieties. Now, if you look at this is mass number. This is atomic number. Now, let's compare it with one of the first 20 elements, calcium, which is 2020. Now, if you look at this mass atomic number is the same thing as number of electron, is the same thing as number of same thing as atomic number. Okay? Now, but we are not interested in electron because electron is not involved in radioactive decay. It is the proton and the neutron content. So it means that the proton is this. Then this one is the mass number. Mass number is what do you call it? Is number of protons per number of neutrons. So it means if I want to know the number of neutrons, I will just subtract this from this. That will be 235 minus 92. Now, if you calculate this, the protons is 92. Neutron will be 235 minus 92. If you subtract that, you get something like 146. Now, for calcium now, the proton is 20. The neutron will be this minus this. That is 0. Okay? Did you understand that? Yes. This is 40. Sorry. The mass number for calcium is 40. So the number of neutron is 20. Now, if you look at this, if you look at the gap between protons and neutron here, 20 minus 20 is 0. That's why it is stable. So elements that have a narrow gap or a near zero gap in the proton content and neutron content in the nucleus are generally stable. Take note of that. But if you look at this, the protons in the uranium is 92. The neutron is 146. There is a wide gap between the proton content and the neutron content. Elements that exhibit that characteristics are said to be what do you call it? Very radioactive because there's a wide gap. So that means there's room for all kinds of reaction, all kinds of activity to take place in the nucleus, making them to be radioactive. So take note of these differences. We'll tag this one part 1. We shall look at the part 2 of this over time. Then we'll also look at balancing the derivative equation in volume 4 of this discussion. So with this, I believe you might have gained 1 or 2 ideas about all these topics that I highlighted above. Please keep subscribing, sharing, and supporting, and keep telling other people about this particular channel. So we'll see you in volume 4.